Good morning, students. So today we'll see how to perform the experiment number 1 in our BEEE course. So the objective of the first experiment is to understand the importance of resistor and also to understand the application of Kirchhoff voltage law and also to verify the Kirchhoff voltage law for the given simple electric circuits. So as we all know that resistor always oppose the flow of electrons, right? So which means we always don't want the resistance property be there on a conductor so that we can allow the current easily, but still in some quiet places we need of resistance to limit the current flow. First, let us try to understand the importance of resistance with the help of one simple circuit. Just look at this circuit. So here what I did is having one battery, DC battery, which is directly connected with the light emitting diode. Right now let us try to make this circuit on this board. Let's see what we are actually seeing. So having battery, this is actually a 9-volt battery, it having two terminals, plus and minus. With that I'm going to connect one more LED in series. See, this is what actually LED in sense it is a light emitting diode. Usually it having two terminals, one is anode, the other one is cathode. The one which is longer is actually anode terminal, the one which is shorter is actually a cathode terminal. Okay, so now what I have to do is I should connect positive terminal of the battery with the anode, and then cathode must be connected to the negative terminal of the battery. Okay, so let us do this one first. So this is what the positive terminal and this is what the negative terminal. So let's fix anode to the positive terminal of the battery. So I'm connecting in series. You know already, if you want to connect in series, you should connect both the component one after another. Right, now let's connect cathode with the negative. So when I connect, you just see very carefully what is going to happen. So now I am putting this cathode with the negative terminal of the battery. See, the moment I connect, you can see that the bulb get failed. Right, you see that initially it is glow and then it is burn out. The reason behind is that all the electrical appliances having certain capacity. So if you pass more than the amount of current which can withstand, it will fail obviously. That is what happening over here. So this battery supply more current to the this bulb so that the bulb get actually burned. Now in this case only we can make use of a resistor to limit the current so that we can save this LED. Now let's see how to choose the resistor so that this LED will be in safer condition. And again, we cannot put a resistor randomly, right? If you put a more resistor, then current will be minimum, then this bulb will not get the actual current, then sometimes it may not work properly. And similarly, if you put a very small resistance, then again there will be a problem. It may take a larger current and again it may fail. So we have to choose the resistance optimally to make this LED work properly. Now for that we are going to make use of the law called Kirchhoff voltage law. Now what I am going to do is I am going to introduce the resistor in this circuit. I am adding a resistor in series with the supply as well as LED. Now this resistor will limit the current so that this LED will get limited amount of current so that it will be in a safer condition. Now our task is to find out the resistance of this particular resistor so that this LED will get an optimal current. Okay, now for that only we are going to apply Kirchhoff voltage law. Right, so first of all we try to understand what is Kirchhoff voltage law. So Kirchhoff voltage law is nothing but in any closed circuit. So this is what actually a closed circuit. You see, we are starting from here and it is ends on here. So it is a closed circuit. So in any closed circuit, always the sum of voltage rise, or in other word we can say potential rise, will be always equal to sum of potential drop. Right, rise means it is the voltage which is given by the source. Drop means the voltage which is taken by the electrical appliances. Right, that is what drop. If you look at this particular simple circuit, here we are having one source which is going to provide the voltage, and we are having two electrical appliances which is going to take the voltage. Right, this resistor is going to take some voltage. Similarly, this LED is going to take some voltage. Right, So now let us try to apply the Kirchhoff voltage law for this circuit. So I am going to take voltage across supply as Vs, voltage across resistor as Vr, voltage across LED as VLED. Okay, now as per Kirchhoff voltage law, sum of potential rise. So we are having only one potential rise over here, so that I write it over this side, which is equal to sum of potential drop. So there are two drops, one is on resistor, one is on LED. Let us try to sum up both. So which is equal to VR plus VLED. Okay, so here we are actually using 9 volt battery. So I'm going to take the supply voltage as 9 volt and the voltage across resistor, as per Ohm's law we can write the voltage across resistor as current through the resistor, right, and its resistance value, that is I into R, plus voltage across LED, right. Actually here we are using a red color LED. For red color LED the voltage drop usually will be a 2 volt. Okay, so that I am going to take as it is. So this is called as forward voltage, which means above this voltage LED get triggered and it will actually glow brightly. Right, now let us simplify this. So I can write IR, okay, which is equal to 9 minus 2, which is 7. Right, now R is nothing but 7 divided by IR. So IR is actually current through this particular circuit, right, because this is series. Series means only one current which is going to be flow through all the components, right. So now this is actually LED. For this LED, that is for red color LED, we can allow the maximum current up to 20 milliampere. So we can allow up to maximum of 20 milliampere through this LED, right. So let us substitute over here. So what it tells us, so we can allow maximum of 20 milliampere to this LED. If you allow more than that, then obviously LED will fail. That is what we visualized on the previous case. Okay, without resistor, when we give a 9 volt directly to the LED, this it supplies more than 20 milliampere current to the LED, which makes the LED to burn. Right, now in order to overcome that only, we are adding a resistor in this circuit. Okay, now let us calculate what is the optimal resistance we should keep so that the LED will work in a safer mode. Right, so 7 divided by 20 milliampere, 20 into 10 power minus 3, which can be written as 0.02. So if you simplify this, you will get resistance of 350 ohm. Okay, so which means if you add a 350 ohm resistance on this circuit, then your LED will work under safer mode. Okay, right, now we have to choose a resistance of 350 ohm for this circuit. Right, now the next question is, so once you have decided what resistance you are going to keep, you should find out what is the maximum wattage rate of resistor. Because resistor having resistance property and also it having certain wattage. So usually in market there will be a 3 basic wattage rating. It will be around quarter watt, half watt and 1 watt resistor. This is the available wattage resistor value in the market. Okay, now for our circuit, for this 350 ohm, let us try to find out what is the wattage needed. So you know that power formula P equal to I squared R. Okay, and we found already the resistance is 350 and the maximum current which can be passed through this resistor is a 20 milliampere for this particular LED. So let us substitute this both over here. So 20 into 10 power minus 3 whole square into resistance is 350. So if you simplify this, you will get around 0.14 watts. Okay, this is theoretical value, but as I said already, in market we won't get exactly this 0.14 wattage resistor. So we have to choose a resistor and that must be greater than this value. So for example, we are having quarter watt resistor which is obviously above 0.14. So either we can go with the quarter watt or half watt or 1 watt resistor for our circuit board. So now we have to choose a resistance of 350 ohm, right, having the wattage which is more than this 0.14 watt, so that the LED will work under safer mode. Okay, now let us now try to apply this onto this board and we'll see whether the LED is working properly or not. Okay, and then you will be given with actually a 2 table, right. One is to understand the importance of resistance, and the other one is to verify the Kirchhoff voltage law. So what we did is we have chosen a supply voltage of battery with a 9 volt, right, and we have calculated the resistance of 350 ohm, right. One more thing you need to understand over here, in sometimes in laboratory you will not get exactly this 350 ohm, okay. So based on the available resistance we have to choose the practical resistance value. For say example, if we don't have 350 ohm, I may have a 200 ohm, right, at that I can choose, and that is going to be a practical resistance. So it depends on the availability of resistance in our lab. Then what you have calculated theoretical, we have calculated theoretical resistance of, that is theoretical wattage of 0.14 watt, and as I said already, we won't get exactly that 0.14 watt wattage resistor, so we have to go with above than that. So we can go with quarter watt resistor, which is obviously available in our laboratory, right. Then coming to this 350, as I said, here I don't have exactly 350 ohm resistor. Instead of that, I having one resistor having 200 ohm, one more resistor having 250 ohm. Okay, so I'm going to use both. I'm going to connect both in series, so to form the resistance, right. So the practical resistance I am choosing 450. So always ensure that you are choosing a practical resistance which is more than the theoretical resistance. So as I said already, I having resistance of 200 and 250. Both I'm going to make on my circuit. Okay. Now let us connect this circuit on the board. So this circuit I'm going to build now. Now let's see in this case whether the LED is working properly or not. This LED is actually getting damaged because we are directly connected with the battery, which supply larger current to this LED. So I'm removing this LED now and keep it aside. Now let's take one new LED. Okay, right. Now first this is plus terminal, minus terminal, red color plus, black color minus. So first I need to connect a resistance. See, as I said, having two resistance, one is 200, one is 250. So I want to form 450 ohm. So which means I have to connect these two resistance in series. Okay, so let's start with the positive terminal first. This is what positive terminal of the battery. See here, plus 2, first resistance terminal. Okay, that I put it over here. Then I want to connect again this resistor in series. So let's start from here in the same column. Then you put it over somewhere else. Right, this is the overall resistance now. Then from the resistance I have to connect the anode terminal. And as I said already, so there are two terminals. One with a longer end is anode, one with a shorter end is a cathode. So let us connect anode over here, and this one I will put it somewhere else. Okay, then I have to connect this cathode to the negative terminal of the battery. See, all are in series. I am connecting one after another. So let's keep it on the same column. Okay, put it on the negative. Now you can see the LED is glowing brightly and without any problem. So which means we limited the current through this particular LED, so that now the LED is working in very safer condition. Okay, right. So now based on the LED size and also the based on LED color, we have to calculate the resistance. Right, now you just see that this is working very properly. Okay, but remember, in laboratory, instead of this battery, we'll provide a device called regulated power supply. Okay, we won't provide a battery. Instead of that, we provide regulated power supply, which we simply call it as RPS. With the help of this device, you can give a DC voltage up from 0 to 30 volt, which means you can give minimum of 0 volt to the circuit with the help of this RPS, or you can give maximum of 30 volt to the circuit. Okay, right. Now, so now we built a circuit and we have calculated the optimal resistance to make the LED work in safer condition. Now let us verify the Kirchhoff voltage law. As I said already, as per Kirchhoff voltage law, the sum of potential rise equal to sum of potential drop. So here the rise is given by the battery and drop will happen on the resistor as well as LED. Right, now we have to measure practically what is the voltage across this battery and what is the voltage across the resistor and what is the voltage across LED. Okay, let us measure it. For that, having a meter called digital multimeter. This meter will help us to measure the various electrical parameters. So this is actually all about a DC. So first I have to set DC voltage measurement. Okay, let us set it on a DC voltage. See, this is a DC voltage measurement point. Okay, let us first measure the voltage across the battery, right? That I am going to fill it up on this table. Okay, so let us measure voltage across the battery. See, again it having two terminals, positive and negative. So let's keep this positive, negative. Just look at the battery voltage. I think this is positive, this is negative. Just look at the battery voltage. We are getting around 8 volt. Okay, we are getting around 8 volt, right? Actually the battery voltage is 9 volt. I think 1 volt is actually dried already. We are using this battery for longer time, right? So we are having supply voltage of 8. So let us take the supply voltage as 8. Okay, now I have to measure the voltage across the resistor. See, resistor, now this is the one end, this is the other end. Across this two end I have to find out what is the voltage drop. So let's keep one terminal over here, other terminal over here. You see what is the voltage you are getting? We are getting around 5.3 volt. This is the voltage across resistor. So let's put voltage across resistors 5.3. Okay, then we'll measure the voltage across LED. So again, LED anode terminal, cathode terminal. Positive you connect to anode and this you keep it as cathode. You see we are getting voltage drop of around 2.7 volt. Okay, right, 2.7. Now you just sum it up everything. So as per Kirchhoff voltage law, summation of these two, that is voltage across resistor and voltage across LED, must be equal to the supply voltage. So if you add this two, 5.3 plus and 6 plus 2, we are getting 8 volt, right? See, 5.3 plus 2.7 is 8 volt, which is equivalent to the supply voltage. So which means the potential rise is actually equal to potential drop. These two are potential drop. So that we can say, Kirchhoff voltage law is verified, right? This is how we need to perform. So in laboratory we will provide the multimeter, the same thing you should do, and we also provide the different supply voltage. Maybe for your better understanding, you will be given with 2 or 3 more supply voltage. So you have to repeat all the same tests, same procedure for all the given supply voltage. Thank you.